Hello, my name is Mario and I will be giving a quick demo on my deep learning program for signals alongside with a workflow explanation and explanation on integration with the rest of the Senior 2 project team and the research team working under Dr. Gonzalez. To begin, we will be using LabVIEW, either an average power program or the spectrogram program. The spectrogram gives us a waterfall with a time frequency graph. The average power shows us a power versus frequency graph for the signals. They are both useful. We will be using both. For this example, I will be using the spectrogram. This spectrogram, like I said, gives us a waterfall image of the time frequency graph for specific signals. Here we will be running a signal, LTE signal of 1.9375 gigahertz. When we click run, the antenna should gather any LTE signals around and show us an image that looks roughly like this, as this was already ran. Once we have received this image, we need to now capture this image so that we can put it in a folder for the deep learning. Now, reason being why we are using the images now versus later is because we know exactly what signals we are testing. For future use, when the user is gathering frequencies, they will not know right off the bat, just looking at this image, what frequency this is or what frequency they're picking up. So we are taking it upon ourselves to grab the frequencies ahead of time so that in the future, when they receive new images, the system can already classify them to where they belong. So like I said, right now we will be grabbing an image. Eventually we will be integrating it so that this goes directly in to the LTE folder. But because we are not there yet, I will be using the snipping tool. This lets us grab specifically just the image of the graph. So we will clip this and save it. The name of the image does not matter. I specifically label them based on which image we have taken. So this would be 0058, as this is my 58th image in this folder. What really truly matters is the name of the folder, which I will explain right now. Now that we have the image, we will be going into the EVE AI training tool. The EVE AI training tool, as you will see here in a second, will be picking up images from our LTE and non-LTE folders, which will fall under the train, test, and validate folder. In each one of these, when you click, you will see something that looks like this, LTE and not LTE. Let's go with the train folder. As you can see, here we have LTE images versus non-LTE images. What this does is the system picks up images to train itself with. So let's say it picks up an LTE image. It will then test it alongside with an image from the test folder. After it's tested itself in there, it will validate its answer through images on the validate folder. Now, the model folder is kept empty as these are the weights used during the epochs for it to learn. This we do not touch, the system will generate it on its own. So now let us open up the EVE AI training tool. You were given two options, a CPU and GPU option. Being that we are using images and a very strong program here, or very heavy program I should say, we are going to go with a GPU. CPU also works, but it takes a lot longer and we might run into some issues. It also does not do continuous learning as GPU does. So we will run this program. Now we have our different libraries. As you can see, we have some demos that were preset with this program, but our folder specifically is the LTE folder. Here you can see that it has stored our validate, test, and train folder up here already. This is where our images are at. From here, we can set parameters to these images. If we want to zoom, if we want to flip the images, we do not want to modify these images, so we will keep them where they are, and we will begin the training. The training will begin blankly like this, and here's where our results will show up. This may take a while, but just for an explanation, here we will see some movement of some lines. These lines will be all bunched up together as it is still learning. It has not differentiated the image from one to the next. So as time goes by, these lines that will eventually pop up, as you can see right here now, will begin to spread apart more. So they will start very close, and we know it's learning the further apart it moves because it's now starting to differentiate one image from the next. Again, very, very close right here. One drawback to this demo, admittingly, it's being that did not grab enough images. This will require a massive amount of images, roughly in the hundreds if not thousands. Also, another down part was that is that I have more LTE signal images than I have non-LTE signal images. So it is really hard for it to compare one to the next when there are more of one than the other. We want an equal amount of images so that it has an equal amount of learning. But as you can see, like I stated at the beginning, it's very, very close together. As it goes, it is starting to spread apart. While this is going on, I will explain an importance of this project for the rest, integration for the team. The rest of the team is working on both an omnidirectional antenna and a directional antenna, a directional antenna and a GPS system to detect where these towers are coming from. While the integration directly for the GPS to me does not apply, integration with the other antenna does highly apply, as once they have their antenna fully functioning, they will be able to run their signals in the LabVIEW program, which we can then immediately pick up and put them on folders to begin training. Also, this program is only functioning between LTE and non-LTE signals. Eventually, we will begin training it with multiple signals for multiple carriers, such as LTE, Bluetooth, Wi-Fi, and give it more of a discernment as to which frequency belongs to where. This will work in the favor for the rest of the team, as their antenna only has to pick up signals from the specific bandwidth, and with this program we will be able to differentiate the signals that are being picked up. With the GPS program, we will be able to locate where those signals are coming from, and because of this, we will know where those signals are coming from and what they are. So we will be able to know if they are a cell phone tower or if it is a moving object such as someone using a Bluetooth device. This program continues learning. As you can see, it's getting a lot better. This is getting more cleaned up, more spread out the longer we give it. For demo's sake, I'm going to stop training right here. Now, this predict button will pop up. This is where it tells us what it has learned. On the top of the image, right here, on the top of this image, it will give us what it has learned alongside with the results as to what it thinks it is. On the bright side, this is from an LTE folder. So this image, we know that it's an LTE because it comes from this folder. This is what it inferred it to be. So the system now knows that that is an LTE file, image. Now if I were to go to a non-LTE folder, as I said, it does not have as many non-LTE images, so at the time being, it recognized this as an LTE signal when it actually is not. Like I said before, we just need more images. Eventually, it will be able to differentiate what signals are popping up where. That way, we will be able to get our answer as to what type of frequency it is. And once we apply the other signals, such as Bluetooth, Wi-Fi, LTE, 5G, anything else, well, as we begin training it, when after it's done training, uh, the system should automatically look into those folders and let us know what it is that it found in the folder. So right now, they recognize this as an LTE signal. Again, that is wrong. It requires a little bit more training. But this is how we train the system. At this point, our model folder should have its best weights that help to differentiate and the average weights. Again, we don't touch those tools. This same process can go with the average power. We get as many images of LTE or non-LTE signals, put them in their appropriate folders, and run the program. Now, something that is very much needed to be said, the images used in validate, train, and test must all be different, such as the folders need to be labeled the same, but these images are not the same as the test folder LTE or the validate LTE. This is so that it gives the system a method of learning. If all the images are exactly the same, then when something changes, even if it's in the appropriate folder, it will not recognize it. So this is how the system is trained. The rest of the, now that I've explained the integration with the senior project team, the integration with the research team will be pretty much the same. They will be using this program to differentiate the signals that they are picking up. Specifically, this is how I got the average power program and the spectrogram program. This will this will allow us to grab future information from signals that are gathered. Now, keynote, something that I did personally, as you saw, my images are specifically labeled by numbers. The reason I do this is so that when the signal, either the Senior 2 project team or the research team pick up a brand new signal, we know for a fact that the new signal is the very last one that they used. So when they go back to these libraries, all they have to do is look for the last signal they found. In this case, it would be 0.0054. This will be the very last one they picked up, and it'll let them know up in the top what signal that is. Thank you.